This presentation for Unit 5 of Science of Our World is related to the following objectives. Critique a theory that explains the origin of the universe. Describe the Doppler effect and how it can be used to explain the expansion of the universe. Discuss from a historical perspective the use of evidence, reasoning, argument, and accident to uncover truths about the universe we live in. Demonstrate understanding of current areas of research in solar and stellar astronomy and stellar evolution, including which major phenomena remain unresolved matters of active scientific investigation. The Big Bang Theory. How did the universe begin? The Big Bang Theory attempts to explain the question using discoveries in the area of astronomy and physics. According to the theory, our universe came into existence about 13.8 billion years ago from a singularity. What is a singularity? A true singularity is a zone at the core of a black hole that is under infinitely intense gravitational pressure. The matter is infinitely small, infinitely hot, and infinitely dense. What happened next? After the singularity's initial appearance, it apparently exploded through the colossal Big Bang event and began cooling, going from infinitely small and infinitely hot to the size and temperature of our current universe. The universe continues to expand and cool. We are found in it, intelligent beings on a planet suitable to life, revolving around a star along with hundreds of billions more stars in a galaxy amongst billions more galaxies. Within this universe exists the dark matter where further galaxies and their stars are born. The cycle continues as stars die and coalesce to form new dark matter for future breeding grounds of galaxies and stars. Questions to consider. Are all black holes singularities? This may not have been clearly defined by science, but to me it seems that while black holes in space today appear to approach infinitely small, infinitely dense, and infinitely hot conditions, and since they defy space and time, they would appear to be singularities. However, since they do not contain all matter and energy, they cannot be true singularities, and they cannot actually be infinitely dense and hot either. Is our universe a true singularity? There is really no way of knowing if our universe actually contains all of the space and matter in existence. According to calculations of astrophysicists, including Stephen Hawking, time and space had a finite beginning that corresponded to the origin of matter and energy. Therefore, the space began inside the singularity. No one knows what was before. Perhaps there was nothing. What is the Doppler effect? The Doppler effect is the change in frequency of a wave or other periodic event for an observer moving relative to its source. When the sound source moves towards you, the wavelength decreases and the frequency of the sound increases, which is a higher pitch. When the sound source moves away from you, the wavelength increases and the frequency of the sound decreases to a lower pitch. I'd like you to pause the PowerPoint for a few moments now to watch this video to see how the Doppler effect affects sound and light. How does the Doppler effect support the Big Bang theory? Galaxies seem to move away from us at speeds proportional to their distance. Edwin Hubble discovered this in 1929 in a study using light received from distant galaxies, and it's called Hubble's law. Using a mass spectrometer, he was able to separate visible starlight into spectra. He observed that the light is systematically shifted toward the red end of the spectrum for stars outside our local cluster of galaxies. Red light has the lowest frequency of visible light. Its waves are farthest apart. Therefore, stars showing a red shift are moving away from us. The fact that these stars are moving away from us supports the idea that the universe is expanding, part of the Big Bang theory. How does the abundance of hydrogen and helium support the Big Bang theory? In 1948, George Gamow and Ralph Alpher developed a convincing mathematical description of how the universe could have evolved by starting with the density of matter in the universe today and envisioning what the past would be like if time went backward and everything were compressed into a denser state. They hypothesized that as pressure increased, so would temperature, and molecules would be broken down into atoms and atoms broken into subatomic particles. Turning the hands of the clock forward, atoms would come together. Scientists believe that when the Big Bang occurred, atoms could not form due to the intense heat. Quickly and steadily, the temperature went down. Within minutes, heavier particles combined to form what are called protons and neutrons, which later combined with electrons to make the simplest atoms, hydrogen and helium. About 75% of hydrogen atoms and 25% of helium atoms make up the observable universe. How do we know this? In discussing the Doppler effect, we learned that the spectroscope can be used to determine shifting of wavelengths and frequency depending upon the motion of the objects receiving and emitting the light. Spectroscopes can also be used to study atoms. Each atom gives off light. Atoms of each element give off different line spectra. Look at the spectrum for hydrogen. No other atom has the same pattern. Here is the line spectrum for a helium atom. It is also unique. Using the spectroscope data obtained from light from stars and galaxies, scientists have found that the observable universe is made of about 75% hydrogen and 25% helium. The amount of these elements in the universe helps scientists understand the universal expansion rate. Consider the diagram. In the hot early universe, protons and neutrons were equally numerous since the energy was high enough to convert them freely back and forth. Once temperatures cooled to 3 × 10⁻⁻⁴ Kelvin, the free neutrons began to decay faster than they were produced. So the unstable neutrons combined to produce helium. So then helium became more abundant than hydrogen. This might seem a little difficult to understand, but if you just look at the diagram really closely, it'll begin to make sense. So now scientists believe that if the universe had expanded any faster, there would have been even more helium. This information not only tells us that the universe was expanding in the past, but tells us how fast it expanded. What about other elements? The heavy elements were made later in huge stars. Only the lightest elements were built up in the early universe. What is cosmic microwave background radiation, and how does it support the Big Bang Theory? Final evidence that supports the Big Bang Theory is the presence of CMB in the universe. The singularity that became our universe was hot beyond measure. Upon the Big Bang, the universe began to cool. At the beginning of its expansion, it was much hotter than it is now. So there should still be some evidence of heat that once existed. In 1965, radio astronomers Arno Penzias and Robert Wilson discovered a 2.725 degree Kelvin, which is equal to negative 454.765 degrees Fahrenheit, or negative 270.425 degrees Celsius, CMB, which pervades the observable universe. This is thought to be the remnant of heat, which scientists were looking for. Penzias and Wilson shared in the 1978 Nobel Prize for Physics for their discovery. With the supporting data related to the redshift, the relative amounts of observable hydrogen and helium in the universe, and cosmic microwave background radiation, the evidence points to an expanding universe that originated in an infinitesimally small, dense, and hot point, and upon the Big Bang event grew to become and will continue to be ever larger, less compact, and cooler. Since there is not a way to step 13.8 billion years into the past, there is no manner in which the theory will ever be proven, but it is with advancing technologies and discoveries that further light will be shed upon it. Go ahead and assess your understanding by answering the following questions. Do you think the universe is contracting? Provide evidence to support your view. Describe the Doppler effect and how it can be used to explain the expansion of the universe. How abundant are hydrogen and helium, and why are there different amounts of these elements in the observable universe? Explain how spectroscopes are used. How is a spectrograph used to determine the movement of celestial bodies? How is one used in order to analyze light from distant stars and galaxies? What is cosmic microwave background radiation, and how does it support the Big Bang Theory? What do you think is an area of research that can be explored in order to achieve greater support for the Big Bang Theory? What do you think will happen once the universe cools completely? Thank you for watching this unit's presentation. You have a great week.